Now guys, name two properties that y equals sine theta and y equals cos theta have in common. Well, first thing I want you to know is that this graph here in red, that's going to be cos theta, okay? Because cos theta starts off at cos 0 equals 1. So you're going to put them both into your calculators and then you're going to draw them accordingly. So that's cos theta there. Now, first thing you might know is about cos theta and sine theta. They're both bound in between 1 and minus 1. So minus 1 on, plus 1 on top, minus 1 on the bottom. Two properties that I have in common, they have the same range. And the same range basically means to go from minus 1 to 1. Next thing, when do they repeat each other? When is the period of the pattern? Okay, so they have the same range. Now let's see about the same period. This cos starts off with at the number 1 going directly downwards. When does this happen again? 360. The period of cos theta's period is 360 degrees. Now let's look at sine theta. Sine theta starts off at 0 going directly upwards. When does this happen again? 360. So both sine theta and cos theta have a period of 360 and they also have the same range. Okay, now find three significant differences between y equals tan theta and either y equals sine theta or cos theta. Okay, so go on. Now it's a graph of, we have a graph of y equals tan x on the board. Okay, now what we're just going to put in is into our table function, we're going to put f of x equals tan x. Okay, once we've done that, okay, so what we're doing here is we're starting at 0, we're going up in we're going to end at, let's say, 360 just to get the full 360 degrees in, and then we're going up in steps of 15. Okay, now we can see here, just look at our graph. This one here is 0 degrees. The next time it's 0 degrees. Next time it's worth 0. It's all the way up to 180. See 180? 180 degrees is the next 0. And then after that it's going to be 360. Okay. Next thing to note is, what value can it not go by? Well, it seems to be that it can't go by 90 degrees. So halfway in between the two of these, there's going to be a line. The line is in here, and this is going to be your 90 degree line. Then you have, do you remember what I was saying about the asymptotes earlier on, guys? Remember I said it can't cross, the graph can't cross here. So that's going to be, this is going to be 90. The next one is going to be, the next error, 270. And then by the same pattern, the next one after that should be 450. Now guys, two significant differences. Okay, the graph is it three significant differences or two significant differences? Three significant differences. First difference is it has a different range. What do we mean by different range? It's not stuck between 1 and minus 1. You can see that tan just keeps going upwards and downwards. There is no limit to tan. It just keeps going on and on and on and on. No range. Sorry, different ranges, okay? Next difference is, when does it repeat itself? When is that 0 going diagonally right up? 180. So the period is 180. Period equals 180 degrees. And finally, third difference. Tan has asymptotes. Now what do we mean by asymptotes? Vertical lines that prevent it from crossing. Also, tan is not a continuous line. Do you understand what I mean by continuous line? There's a break in it. Do you understand? It doesn't join up, while in sine and cos it does. Okay guys, with number 12 guys, what we're going to do is we're going to draw the graph y equals sine theta plus cos theta for 0 to 360. You go to your calculator and you're going to put in sine x and cos x. So there's sine x there, plus cos x, and you're going to go from 0 to 360, and we'll go up in our blocks of 15. Now, like last time, what you're going to do is you're just going to match up your values. Okay? So we're going to go up at when it's 45, our answer is 1.4. That's a graph there. So that's 1.4 there. When it's sorry about that. When it's 30, it's 1.3. That's 1.3 there. When it's 0, it's 1, which is here. And then basically 135, it's 0. 180, it's minus 1. 225, it's minus 1.4. 270, it's minus 1. And 315, it's back to 0. And 360, it's back to 1. And basically you just join all these points together to get a rough representation of your graph. So basically all I'm doing here, guys, is I'm just plotting all these points. I'm not going to plot them all because it'll take too long, but I'm just plotting just enough that I can get a rough gauge. So like 120 would be 0.3, which would be around here. Okay, then I could do another one in between there. So I could go for 90 degrees, which is 90 degrees is worth 1. And then I could just join all the dots together to get my graph. Okay, that's perfect. Now, they go, what is the period and what is the range of this function? So let's start off at the beginning. At the beginning, we're going diagonally right up at the number 1. At the very end, what's going on? Sorry? We're going diagonally right up at number 1. So that means that the period is 360. Period is 360. Now they ask next, what is the range? Okay, and to be honest, on our calculator, we're looking for the highest and the lowest value. The highest value is going to be 1.4142, and the lowest value is going to be minus 1.4142. 414. So it's going to be 1.414 on top and minus 1.414 on the bottom. Now guys, 414, these are actually the same value as root 2. You wouldn't lose marks if you didn't know that. So you could also write down this answer as being minus 1.414 brackets 1.414. Okay, that's that answer there. Now, I want to see what we have here is 3 graphs drawn. We have y equals cos x, y equals sin x, and y equals sin x plus cos x. Okay? Now, we're going to see here if I can just grab this. Okay. Object properties. Now I might try and change the colour on it. Just give me a second. There we go. So, green, okay? Done. The green one is sin x plus cos x. Okay? The red one is which, guys? The red one is sin x, and the black one is cos x. Okay? Now look what happens. The height of the black is added to the height of the red to give you the height of the green. So for instance, at this part here, the black is only this high, the red is this high, and when you add those two lengths together, you get how high the green one is. So in effect, you're just adding the heights up and down. Okay? Now this is an interesting one here, okay? The black is below the line, okay, and the red is above the line. Okay, and you see this time you actually have to take them away from each other because one of them's above the line, the other one is below the line. So when you add their heights, you're going to get the green part in between, the green height. Does that make sense? Okay, perfect. Connor.
Is any relation like